In this video, we'll begin our discussion of what sine is. So I need to preface this video because I'm gonna show you a little clip. It's an animation of me using a program online to get a point across. First thing I wanna point out to you, everything that's going on here. So in this program, I drew a triangle to an angle, 19.9 degrees. It's not going to change. 19.9 degrees, it's going to stay consistent. And what I'm going to do is I'm going to move this side that's right here. Let me color. This side right here, I'm going to move it back and forth, and we're going to take a look at some measurements to put something together. So right here, I'm just going to show you what each one of these are so you know when I'm playing the video what to look for. This BC is this length right here. So notice right now where it's sitting, it's equal to 8.6. It will be it rounded some way, but it'll round it and keep it there. Oh, it looks like some of these kind of slowed down in the video where I screenshotted at. But AC will be 23.7. Well, AC is this length right here. So it is about that, but I caught it while it was moving. So forgive me because it couldn't keep up. And then the AB is this side right here. So all three of these are just measurements of the sides of the triangle. That's it. Right, and they'll be accurate when I move this C around. These values will change. This is why they're not accurate here. Is because I was moving them when I took my screenshot. So you'll see that move. And then the last thing I'm going to do, and I'm going to show you why this is important and why it came about. We're going to take this side right here, BC, and we're going to divide it by this side right here, AB. And we're going to take these two things and we're going to divide them and see what happens. You're going to see a special relationship that as long as I keep this angle here equal, right, I don't change it from 19.9, there's going to be a special relationship when I divide these two, BC over AB. This is what we call sine, and we call it like this. Sine of 19.9 degrees is going to be, this is 0.3. The question is, what's going to happen when I change my triangle? So I'm just going to show the video here within my video. So hopefully you can see this okay. I'm going to push play, and you can see how this is changing. I went way out the screen, made it smaller. I can make it down all the way down to a very, very tiny triangle. But what I want you to notice in this animation, notice all the values on the left side, BC, AC, and AB are all changing, which means, and there's my very small triangle there, and I'm dividing BC over AB when I change it, and no matter what I change it to, as long as that angle 19.9 degrees stayed, my sine of that angle, this ratio, this division, all it is a division. That's all. It's a special name. We say sine is this ratio of the sides. And it ends up being, if you look, BC is the side that is opposite of my angle, right? And then I took that side that was opposite of my angle, or even the y there, right? It's a y value up and down, and I divided it by the hypotenuse, right? And we saw that no matter where we moved my triangle, as long as that 19.9 degrees held, I got the same ratio every time. I got 0.3. So what does that mean? Well, let's go back to our notes here. That if I want to find sine of an angle, this is the definition of sine, all it is y over r, right? It's y over r is my distance, the hypotenuse. So if you take a look here, right, if I take any of those triangles that I have and I divide y prime over r prime, or y over r, or y double prime over r double prime, I always get that 0.3 if it was a 19.9. Now, the sine ratio won't always be 0.3. If I change the angle, right, if it wasn't a 19.9 and I change the angle, the sine will change. Sine is completely based on the angle we're talking about. Okay, well, if it doesn't matter what the sides are of our triangle, we should make our life as easy as possible, and we should let that r be a 1, right? Like, then it creates these triangles for us that has a 1 right here and then some other sides. This relates back to the two videos that you watched before this. We have what these triangles are going to turn out to be. You're going to have to memorize those values and get to it. But if I can just let that be a 1, well, what happens here is this is a y, right? And this was my r, but now it equals 1. Then sine of theta is actually just equal to y over 1. Well, anything over 1 is just itself, so this is sine theta equals y. Now, this is only when r equals 1. Okay, I wrote that right down here. Given xy on a unit circle, right? If the radius is 1, like the pictures that we've been looking at in the past videos, if the radius of my circle is 1, then I have this very special ratio right here. This is huge. This is going to be the rest of your stem. You're going to use so much sines and cosines. Sine is y over r. That is the actual definition. Sine is y over r, where r is the radius or the hypotenuse. We could even say y over h if you would like. And we're going to relate this to some triangles. There's probably an acronym that you guys are used to. I will show you that, but the way that your book starts with it is very based on this just observation that sine is this division of sides that we just named it that, right? We could have named it anything else, but this division of our two sides given an angle of the triangle we can create from that angle gives us our sine. Okay, so what does this mean? Let's find some examples. These are back to what we were talking about. These are these special degrees. Okay, 60 degrees. Okay, I want you to remember how we get to everything we need. Remember, this is pi over 3. Okay, pi over 3 from those past triangles, past videos, tells me it's a tall triangle, which means I draw my triangle. This is the tall one. And remember, this side's 1. Now we know why, right? Because my ratio of the sides aren't going to change, so I might as well make that a 1. But I know from previous videos, if this is a 60, right, and that's a 30, and this is my tall triangle, that means the tall part is bigger, so that's the radical 3 over 2, and the small side is 1/2. So if I'm doing sine here, okay, well, that's y, right? And this is radical 3 over 2. We just figured that out over here on this, that it's a tall triangle given that it's a pi over 3. So this is a pi over 3 angle. That's a radical 3 over 2. This over here, we get this also. This is radical 3 over 2. This side down here going down is the same, but it's negative radical 3 over 2. And then that same thing over here. We get a negative radical 3 over 2. And then what we're forcing to happen to make it all nice is these are going to have 1s. So when I do my sine, like, okay, so sine of pi over 3, that's this right here, this triangle that we're dealing with. Sine, remember, is just y over r, but r in this case is just a 1. So sine is radical 3 over 2. If you know your 30, 60, 90 values, you will be able to get through these without drawing these giant pictures. And I'll show you how to do that. We're going to do a whole lot. All right. Now I just answer. Remember that sine of these angles, okay, 2 pi over 3, that's going to be all the way over here, 2 pi over 3. That's this revolution like that to here, right? And all I know, okay, I know the sine value is my y value, which is radical 3 over 2 of that triangle. Okay, we have another revolution that we can look at. It would be from here all the way over to here. Okay, well, this is 3 pi over 3. So one more is going to be 4 pi over 3. That's this side right here. So when I do sine of 4 pi over 3, it's just the y of that triangle, which is going to be your negative rad 3 over 2. And this makes sense because this point in the third quadrant is a negative. It's down below. All right, sine 5 pi over 3. That's just adding one more third here. Or you could think about that this is 6 pi over 3 because it's a 2. I go 1 back. Again, the answer is just your y value of that triangle, negative rad 3 over 2. If you have these values down and you can point out tall and short triangles, this sine cosine business really just comes down to the 3 steps. Where's the angle? Which triangle? Short, tall, or middle? And then sine is y. So it'll be my up and down values of those triangles. Right? What about if it was 30 degrees? Well, 30 degrees, it matches that same thing. It's a 30, 60, 90. And I know sine's going to be my y. Okay, well, this is my short triangle. So this is pi over 6. 30 degrees is the same thing. And this is my short triangle. So I draw my short triangle. And to make sense out of it, the big side has to be on the bottom. Right? That the long side is the bottom to make it shorter. All right, so I know that this is 1/2. This angle, okay, well, that's pi over 6 is right here, that value. So this is going to be 5 pi over 6. How I can do that is I know that this is 6 pi over 6 because it's pi. 1 back is 5. 1 forward is 7 pi over 6. We're still looking for that side. This side is 1/2 up here. Down here, this is a negative 1/2. And down here, okay, that's going to be a negative 1/2 as well. And then this angle, okay, if I think about this 12 pi over 6, this is 1 back to 11 pi over 6. So that's how we get that. Okay. So, and I think I copied and pasted these angles. So I'll try to fix your notes. If not, you'll just have to fix them. So these are our 6's. Looks like I forgot to change it. So this is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. What makes this really nice now, because you know your 30, 60, 90 triangles, and you can see that those are halves. Okay, sine y, well, in the first quadrant, sine goes up because it's y is up, so it's a positive. Over here at 5 pi over 6, y goes up, so it's positive, it's a half. Now we're down here, 7 pi over 6, the y is going down, so it's a negative 1/2. And then the last one, this point here at 11 pi over 6, it's going down, it is a negative 1/2. What you're going to end up doing is I'm going to give you a sine, and then we'll deal with the other one, cosine, and there are 4 more after that, but they'll come easy after we do these. You just got to memorize these values. The unit circle all comes down to you knowing your angles, knowing your 30, 60, 90, 45, 45, 90 triangles, and then you just put them together. And then if you know sine is y, you'll be good. And you can probably guess if sine is y, what cosine may be. I won't say, we'll go through the next video. All right, we got one more here. It's our 45-degree ones. Remember, 45 degrees is pi over 4. And remember, pi over 4 is a mid-triangle. So a mid-triangle, we know that both sides are the same, and the radical 2 over 2. That's just from the previous video, right? All our 45, 45, 90s are radical 2 over 2. The hypotenuse is 1, which helps us with the unit circle. So I know if I'm finding sine, okay, here's my first angle. This is going to be pi over 4. And the sine here is radical 2 over 2. Okay, radical 3, pi 3 over 4 is this next one. And the sine is that same length, so it's also a radical 2 over 2. Okay, this point down here is going to be, okay, this is 4 pi over 4, so this is 5 pi over 4. It has the same length, so I know it's a radical 2 over 2, but since sine is wide and y is going down, it's a negative. And then our last one, we got a 7 pi over 4. That is the same, and it's also going down, so it's a negative rad 2 over 2. So these are our special values that show up in our unit circle. These are the only ones you're going to have to memorize. Everything else, we're going to have to use a calculator or some kind of workaround. But these are all the sine values, and if you notice, it's only 3 values. There are more. Sine could be anything, right? It's just the y, so if I were to put a revolution right here, it would be that distance, right? But it's not a pretty one like these. These nice 30, 45, and 60 produce these 30, 60, 90s and 45, 45, 90s. That's why we're focused on them. Is they give us exact values. Everything else in the unit circle, there are some that you can make exact, but they take some work. But everything else for our sine, remember, it's just a y, so I can actually have sines everywhere. Give me any angle, and we can find a sine because I can put that angle right here, draw my triangle, and ask myself what the y is. That is the definition of sine. Sine is take your y and divide it by your hypotenuse, or the radius. The reason that we can just say sine is y, and that's what I'm going to ask a bunch, is what is sine? Sine is y. What is sine? Sine is y. Because in the unit circle, the radius is 1, and we looked in that video, which you can go back and look, no matter how long I made my sides of my triangle, if the angle stays the same, the sine, the division of my sides, my opposite, the y over the hypotenuse, stays the same. So that's why we get to say sine is just y.